Good morning, everyone. First slide. My first point is this, that when we talk about climate change and biodiversity, or the role or interaction of climate change and biodiversity, I think we have to put that in context. So I like to use this language. Let's start thinking about what's our values proposition for biodiversity, okay? What is it that we're saying biodiversity is valuable for Australian society if we're trying to come up with policy, public policy? And there's at least 5 elements, I would argue, to a values proposition for biodiversity from a policy point of view. One is we have legal obligations. Our government signed the CBD. It's brought about an EPBC Act to give effect to that. And embedded within those treaty obligations are actually moral obligations. The CBD recognises the intrinsic value of nature, the value that nature has irrespective of its use to people. So we have legal obligations to fulfil. But there's other values that should be part of our values proposition. Biodiversity has enormous educational value, nature-based teaching and learning for more sustainable ways of living. I've just come from the Healthy Parks, Healthy People conference, which was all focused on the contribution of biodiversity and park protected areas to human health, both physical and mental health. The main sponsor was Medibank, and another participating organisation was Beyond Blue. Okay, so we all know that the high political ranking of education and health in policy issues. Biodiversity is not irrelevant to these issues, it's actually central to them. We're increasingly talking about the role of biodiversity in sustainable livelihoods, especially for Indigenous communities on country, but also other communities living on the rangelands. And people are talking about the role of ecotourism and payments for ecosystem services, which are all dependent upon biodiversity. So in that context, I think we should be talking about climate change and biodiversity in terms of life support systems. Okay? We're embedded and dependent within and dependent upon the biosphere, and we're dependent upon water, and we're dependent upon healthy climate. So this issue of climate change mitigation, helping to halt the climate change problem, and adaptation is really important. So that's my first point. However you look at it, climate change is pretty bad for people, and that's because we've made the fundamental and false assumption that the climate's stable, and it's not. It's highly variable. So if you look at the long-term impacts of rising sea level and threat to food security from changing climate, however it's going to change, they're sufficiently serious to justify strenuous national and global mitigation efforts to stabilise greenhouse gas concentrations. And we also know that, from past climate change, a lot of species went extinct, and that with the future climate change we're going to lose some species. That's inevitable, and some ecosystems are going to change in ways that we don't like. But this is where our message starts to get a bit confused when we think about biodiversity, climate change and policy, because there's also a positive perspective to be placed on biodiversity, climate change interactions. The first is ecosystem-based mitigation. This is an area where my group's doing a lot of research in. The role of natural systems in carbon storage and helping to mitigate atmospheric concentrations of carbon dioxide. We've now got really solid empirical evidence as to just how significant the role of natural ecosystems is in climate change mitigation, because they store such large amounts of carbon. And if that carbon is allowed to be mobilised and released in the atmosphere, we have even less prospect of preventing climate change. And I've got some publications there of ours that you can look up or ask me for copies of. And there's also this concept of ecosystem-based adaptation. This is the role of natural ecosystems in helping humans adapt to the negative impacts of unavoidable climate change. And there's a couple of reports I can point to. I was a contributing author in a report published by the Convention on Biological Diversity Secretariat, technical series number 41, Connecting Biodiversity and Climate Change, Mitigation and Adaptation. So a really simple example of this is the role of mangrove ecosystems in helping to buffer coastal communities from storm surges and rising sea levels and the like. Back a slide. A non-ecosystem based approach is to remove the mangroves and build a concrete wall. Okay, I mean that's the difference between a engineered adaptation and an ecosystem-based adaptation. So between ecosystem-based mitigation and ecosystem-based adaptation, next slide, that's a positive view. But if you think about it, we're kind of being presented with two potentially contradictory scientific perspectives or science-based perspectives on biodiversity and climate change. One is nature, the hapless victim of climate change, predictions of mass extinctions of species, massive decline and degradation of ecosystems. Or secondly, nature's solutions for climate change, ecosystem-based mitigation and ecosystem-based adaptation. So do we have to make a choice here? I mean, is someone right and someone wrong? What's the story? Well, this apparent dichotomy actually reflects something that connects to what Isla was talking about before, and that's the reality that the impacts of climate change on biodiversity are complex, and there's actually a number of factors we've got to consider. So whilst I think for humans, the impacts of climate change in the long term are unavoidably disastrous for most people everywhere, just if we look at sea level rises and food security issues, I can't see any good news for anyone in the long term. On biodiversity, it's a bit more complicated. For a start, not all change is bad. There are going to be winners and losers. There are some species that will be better suited to the changed climatic conditions, and there are others that will be less suited. Some of those species we may not like. Animals that, well, I don't have time to go into examples, but we could all imagine there are species we would like to be winners, and others we would rather not be winners. And also the rare get all the attention. And the rare species are important, but actually if you stand back and look at the biosphere as a whole, most of the biosphere is made up of common and abundant species more than, which are generally widespread. We call these kind of foundation species. So, most of what we call biodiversity, most species are actually low in numbers and have a restricted distribution, but most of what we actually see is more widespread and abundant and probably more resilient. And actually, again, this is something where there's a lot of confusion, but photosynthesis increases with increasing atmospheric concentrations of CO2. Generally speaking, in broad terms, photosynthesising plants like more CO2, not less. And actually, globally, a warmer world's a wetter world, not a drier world, okay?